Hello friends, in today's video we are going to see some again remaining topics regarding our chapter, that is generics. The new topic is eraser. Usually it is not necessary to know the details about how the Java compiler transforms your source code into object code. Okay. So object code is generated. However, in the case of generic, some general understanding of the process is important because it explains why the generic feature works as they do and why their behavior is sometimes a bit surprising. For that purpose, a brief discussion how generics are implemented in Java is in order. For generics, for some topics, some general understanding of the process from transformation of source code into object code is necessary. An important constraint that governed the way that generics were added was the need for the compatibility with the previous versions of the Java. Generic code had to be compatible with the pre-existing non-generic code. For that purpose, generics were added to Java after JDK 5. Thus, any changes to the syntax of the Java language or to the Java virtual machine had to avoid breaking older code. So, older code cannot be broken by the Java virtual machine. Any changes to the syntax of the Java language or to the Java virtual machine had to avoid breaking older code because of generics. The way Java implements generics while satisfying this constraint is through the use of eraser. What is the constraint? It has to avoid older code breaking, and it is implemented by use of eraser. Here is how eraser works. When your Java code is compiled, all generic type information is removed. Okay, so it will be compatible with the older versions of Java. This means replacing the type parameters with their bound type, that is the upper bound, which is the object of no explicit bound is specified, and then applying the appropriate casting to maintain type compatibility with the type specified by the type arguments. Okay, so when the code is actually run, what is happening over here? Everything that is returned to the type parameter, which will be replaced by the actual type that is specified, and if it is not specified, it will be replaced by the object, and then applying the appropriate casting from one data type to another data type, and to maintain the type compatibility, and it is specified by the type arguments at time of object creation. The compiler also enforces this type compatibility. This approach to generics means that no type parameters exist at runtime. Okay, they are simply a source code mechanism, or they will be available only. The T will be available only at the source code creation or compile time. It will be not available at runtime because T is actually replaced by the actual data types. To better understand how eraser works, we will see class generic type T. T object is created. Parameterized constructor generic T object. Object is initialized with O. Return object. T get object. Return object. T is bounded by string. Okay. T extends string. Upper bound is string. Now we will see T string is created. Then there is the second class generic string. The second parameterized constructor and get string will return string. After these two classes are compiled, T in generic will be replaced by actual object. The T in generic string will be replaced by string. Okay. So here T is replaced by the object because type is not specified, upper bound is not given. So base class is object. In this case, object is placed here. And secondly, T extends string, upper bound is string. So it will be replaced by string. Here T is bounded by string. Class generic string, T extends string. Here T will be replaced by string. Okay. Now, after these two classes are compiled, T in generic will be replaced by object. You can confirm this by running Java P on the compiled classes. So what is the output? The class generic extend java.lang.object, and T is replaced by object java.lang.object OB. and java.lang.object get object. Okay, so parameterized constructor is also shown over here, written with the type t. And when your string class is compiled, what is the output? Java.lang.string string. So t will be replaced by string because the upper bound is string. Generic string, parameterized constructor is passed with string, and get string will return the string. Within the code for generic and generic string, casts are employed to ensure proper typing. Okay. Generic integer I object is equal to new generic integer 99, x is equal to I object dot get object. Would be compiled as if it were written like this. Generic I object, new generic 99, and I get object will be cast to wrapper class integer. Okay. So cast are employed here to ensure proper typing or type casting. Then generic I object is equal to new generic 99, and it will be casted to integer. Because of erasure, some things work a bit differently than you might think. For example, consider a new program that will create two objects of the generic gen class as shown here. Now, generic integer I object with the value 99, generic float f object with the value 102.2f. Then I object dot get class dot get name, f object dot get class dot get name. Okay, so output is for both gen. Okay, why? Because the class name of the generic is here gen only. The types of both I object and f object are generic, not the generic integer and generic float that you might have expected. All type parameters are erased during compilation at runtime. Only raw type actually exists. I'm sorry. Bridge methods. The compiler will need to add a bridge method to a class to handle situations in which the type eraser of an overriding method in a subclass does not produce the same eraser as the method in the superclass. Okay, what is the situation? The type eraser of an overriding method in a subclass does not produce the same eraser as the method in the superclass. At that time, bridge method is created by the Java compiler. In this case, method is generated that uses the type eraser of the superclass, and this method calls the method that has the type eraser specified by the subclass. So type eraser of superclass will call the method that has type eraser by the subclass. These methods only occur at the bytecode level, are not seen by you, so you cannot see them and are not available for your use. It is for the sake of Java compiler usage. Although bridge methods are not something that you will normally need to be concerned with, it is still instructive to see a situation in which one is generated. Okay. Normally, this situation never happens, and it is still instructive to see a situation so that you can understand how bridge methods are created. Now, we will see an example for this. Class generic t object. Then pass the constructor reference to object of type t. Generic t object is equal to O, return object. A class subclass of generic to extend generic to string O is placed over here as a parameter. Okay, here t is passed because t is of type object. Here string, that is string object, is created, passed over here as a parameter to the constructor. String get object will return object we call string get object. We will see the situation that requires bridge method. Create generic to object for strings. Okay, so generic to string object 2 is equal to new generic 2. This line will call this constructor of generic to string object, and it will call the super object. Okay, so super object will be calling this constructor generic t object. Object is initialized with O. Then string object 2 dot get object. What is get object? You call the string get object and it will return object. The subclass generic 2 extends generic but does so using a string specific version of generic. Generic 2 extends generic of string. Okay, generic 2 has type object, generic has type string. Inside generic 2, get object is overridden with a string specified as the return type string object, get object. You call the string version of get object. All of this is acceptable. The only trouble is that because of type erasure, the expected form of get object will be object get object. To handle this problem, the compiler generates a bridge method with the preceding signature that calls the string version. Okay, if you examine the class file for generic 2 by using Java P, you can see generic 2 extend generic 2 parameterize constructor get object and bridge method java.length.object get object. Okay, this will create two methods. The bridge method has been included. Okay, because of type erasure, actual form of get object will be object get object. For that purpose, this method has been added in the generic 2 class file. Okay, the comment was added by the author and not by the Java P. There is one last point, so we will see about bridge method. Only difference between the two get object method is their return type. Okay, first get object is returning what? Object type T, and second get object is returning what? String. Okay, normally this would cause an error, but because this does not occur into your source code, it does not cause a problem and it is handled correctly by the Java virtual machine. And the bridge method that is included, it is not seen by you. If you want to see it, you can go to class file. Okay, and you can see the method added over here. Now, ambiguity errors. The inclusion of generics gives rise to new type of error that you must guard against, that is ambiguity. Ambiguity errors occur when erasure causes two seemingly distinct generic declarations to resolve the same erase type, causing a conflict. Okay, so when there are two seemingly distinct generic declarations, they will resolve the same erase type, causing a conflict. Here is an example that involves method overloading. Ambiguity caused by erasure on overloaded method. So that conflict is nothing but the ambiguity. Class myGeneric class T comma V. First type is T, second is V. T object 1 is created, V object 2 is created. These two overloaded methods are ambiguous and will not compile. Set T object 1 is equal to O. V object 2 is equal to O. Okay. So T is also not specified, V is also not specified. They will be known at runtime, so it will create an ambiguity. My generic class declares two generic types T and V. An attempt is made to overload set based on the parameters of type T and V. This looks reasonable because T and V appear to be different types for you, but for compiler they are same because its type is not given over here. There are two ambiguity problems here. First, as my generic class is written, there is no requirement that T and V actually be different types. First of all, okay, you can pass them both as a single parameter to a generic. It is perfectly correct to construct a my generic class as shown here. My generic class string object is equal to new my generic class string. In this case, both T and V will be replaced by string. Okay, this makes both versions of set identical, which is of course an error. Okay, so ambiguity is created over here. Void set TO, void set VO. Okay, here is also string is passed, here is also string is passed, and it will give you error. The second and more fundamental problem is that the type erasure of set reduces both versions to following. Void set object O, because both are of object same type, that is object. Thus the overloading of set is attempted in my generic class is inherently ambiguous. Okay, and these errors are very much tricky to fix. For example, if you know that V will always be of some type of string, you might try to fix my generic class by rewriting its declaration as T comma V extends string. Almost okay. Okay, what is this V type? It will always having the upper bound as string, and T can be anything. So this line is okay. It will not create ambiguity. This change causes my generic class to compile, and you can even instantiate object like one like shown here, my generic class integer string x is equal to new my generic class integer string. So you can instantiate this class as this example. Java can accurately determine which method to call in this case. However, ambiguity returns when you write like this. My generic class string x is equal to my generic class string. In this case, both t and v are string. Which version of set is to be called? It does not know, because one set is having t as a parameter, second set is having v as a parameter, but both are of type object. So at that time, Java compiler does not know which version of set is to be called. The preceding, frankly, in the preceding example, it would be much better to use two separate method names other than overloaded method names rather than trying to overload set method. Okay, so it can be set1 or set2 or any other name you can give it to. Often the solution to ambiguity involves restructuring of the code, because ambiguity often means that you have a conceptual error in your design that your Java compiler does not understand. Some generic restrictions we will see. There are few restrictions that you need to keep in mind when using generic. You can write them down. It is very important. They involve creating objects of type parameters, static members, exceptions, and arrays. So restrictions on all these types we will see one by one. First of all, type parameters that we pass that cannot be instantiated. It is not possible to create an instance of a type parameter you are passing, like class generic t object in default constructor ob is equal to new t. We cannot write like this. This line is wrong. Here it is illegal to attempt to create an instance of t. The reason should be easy to understand because t does not exist at runtime. How would the compiler know what type of object to create? Okay, so t, it is not present at runtime. At runtime, when you are creating object, this t will be replaced by the actual data type. Okay, when you are creating object of type generic integer is equal to new generic integer. Okay, so t will be replaced by integer. So which type of object to create, it does not know. So you cannot write like this. You have to just pass a wrapper class name. Eraser removes all type parameters during the compilation process. So all will look same for the sake of transformation between older code, that is Java 5, older code than Java, and newer code than Java 5. Restriction on static members. No static members can use a type parameter declared by the enclosing class. All of the static members of this class are illegal. Class wrong, type T. No static variables of type T. Okay, static T object. So you cannot create, no static member can use a type parameter declared by the enclosing class. No static member can use T, static T get object. So these two lines are wrong. Cannot use them like this. Okay. No static member can access the object of type T. So it is also wrong. You cannot declare static members that use a type parameter declared by the enclosing class. You can declare static generic methods which define their own type parameters as was done earlier in this chapter. Okay. You can declare static generic methods. Static members cannot use the type parameter declared by the enclosing class, but you can declare static generic methods which define their own data type parameters as was done earlier. Okay. Generic array restriction. There are two important generic restrictions to arrays. You cannot instantiate array whose base type is a type parameter. Okay. You cannot instantiate an array. You cannot create an object of the array whose base type is equal to the type parameter, and you cannot create an array of type specific generic references. Second is you cannot create an array of a type specific generic references. We will see one example. Generic t extends number. Okay, so t object is created, t values array is created. So T values array creation is okay. Generic parameterized constructor T object comma T array numbers. Object is equal to O. This statement is illegal. Values is equal to new T of 10 because it cannot create an array of type T. Okay. Values is equal to nums. This nums value will be initialized to nums. This statement is legal. Okay to assign reference to an existing array. Then generic arrays, integer array 1, 2, 3, 4, 5. In generic integer object is equal to new generic integer 50 comma n. Cannot create an array of type specific generic references. So generic integer generics array is equal to new generic is equal to new generic integer 10. It is wrong. Generic question mark generics is equal to new generic 10 is okay. So type specific generic references you cannot create like this. It is valid to declare reference to an array of type T as this line does. Okay. You are creating reference to an array of type T. It is okay. We cannot instantiate an array of type T because it is of type enclosing class. This type is of enclosing classes as this commented outline attempts. Values equal to new T. Cannot create an array of type T. This is wrong. The reason you can't create an array of type T is that T does not exist at runtime, so there is no way for the compiler to know what type of array to actually create. Okay, so because of erasure, T is actually erased at compile time itself, and at runtime, compiler does not know which type of array to actually create. You can pass the reference to a type compatible array to generic, where object is created and assign that reference to values as the program does in lines. Okay, what does this line tell? You can pass a reference to a type compatible array to generic when an object is created and assign that reference to values, like values is equal to nums. Okay, you are assigning a reference to an existing array. Array passed to generic as a known type which will be same type as T at the time of object creation. Array of nums is equal to array of values, so both are same. Inside main, notice that you cannot declare array of references to a specific generic type. So integer is passed over there in this example. Okay, so specific generic type, specific generic references array you cannot create. Here you are specifically you are giving integer. Here you are giving the wildcard. It is okay. It is not okay. Okay. This line will not compile. Arrays of specific generic types simply are not allowed because they can lead to loss of type safety. Okay. So at the source code time or the compile time, you have to just give the type T. You can create an array of references up to a generic type. If you use a wildcard, you can give it here. While the creation of object, this will be replaced by the actual type. This approach is better than using array of raw type because at least some type checking will still be enforced using a wildcard. Generic exception restriction. A generic class cannot extend throwable. This means that you cannot create generic exception classes. Now, last point on generics theory. Generics are a powerful extension. To summarize, okay, we are summarizing about generics, so you have to write them down. You can take a photo, you can take a screenshot. You have to remember the generics are a powerful extension to Java because they streamline the creation of type-safe reusable code. One-time written code can be reused many times as you need. Although the generic syntax can seem a bit overwhelming at first. What does this line mean? The syntax is just complicated, bit tricky to use. When you will practice it more and more, you will morely understand it. It will become a second nature after you use it a while. So what is the solution for this problem? For the syntax being tricky, you have to use it more and more. You can take more examples and you can solve them on your own. The more you practice it, more you will remember. Generic code will be part of the future for all Java programmers. Okay. So after JDK 5 or Java 5, you cannot omit or you cannot eliminate the use of generic. You cannot avoid the power of generic. Okay. So this way we have completed all generic topics on theory. From the next session, we will look at the practical part of all programs that we have seen in the theory part. We will see them by practical, how they are actually working. So meet you in the next session. Thank you so much.